Okay, so 10E, we're going to look at the inverse. So the inverse is when you raise a matrix to the power of -1. So that's what inverse means. So anything to the power of -1 can be called an inverse. Okay, so if you actually were to, you could write inverse, it could actually be written like this. So when you say something's to the power of -1, it's essentially like saying 1 over. So which we could say is like dividing. Okay? So in matrices, when we use the inverse, when we want to divide, we multiply by the inverse. So you might want to write a little note like that. So in matrices, when we need to divide by a matrix, it'll come, wait a minute. When we need to divide by a matrix, we multiply by inverse. So that's it. We don't actually do division. We use a multiplication of an inverse because it's like the same thing. All right. So if you have that little knowledge in your head, it'll help you with problem solving. So to know that. So, and now the determinant, we're also going to look at finding that. So the determinant, you'll often see written like this. They'll say the determinant of a matrix like that equals. Okay, so the determinant, and what's that? That is used in the inverse formula. Okay, so we need to know how to find that as well. So we'll have a bit looking at that today. All right, so obviously we always have our calculators, and so if you want to find the inverse of a matrix, you can simply, in your calculator, you can just type up your matrix. So you could just type whatever it is and you raise it to the negative power. Now an inverse matrix will always be square because you can only raise a square matrix to a power. So an inverse, you might want to write that as well. An inverse matrix is always square. Okay, so if it's not a square matrix to begin with, you won't be able to get an inverse. Okay, so we could have, as someone just said, we could have a 2 by 2, we could get an inverse of a 2 by 2, a 3 by 3, 4 by 4. We have to manually know, so we have to be able to calculate the inverse only for a 2 by 2. We will need to use bigger ones, but don't need to work them out manually. We can just use our calculator by raising to the -1. So we'll look at that first. So obviously we're going to just be going at the moment, looking at the basics, a 2 by 2, so that we can learn the manual method of finding them. Okay, so what we're going to do is here, so obviously we've got the inverse matrix, and we said it's always going to be a square, and you can raise it to the -1. If you times a matrix by its inverse, so that means you times the original matrix, and then you times it by the same matrix to the power of 1, you will always end up with an identity matrix, which if you remember, has the 1s on the leading diagonal and 0s on the other diagonal. Okay, in the rest. So, and that would actually make sense, because say for example, just to show you, if you had the number 3 and you multiplied it by its inverse, which remember I said was like 1 over the number, so you would end up with 1, don't you? Because 3 over 3, so 1. So when you multiply a matrix by its inverse, you would get the identity matrix. So just to help to see this, to prove this, and also to help with our manual multiplication, which we just did in 11D, we're going to do this equation here. So it says show that matrix A equals this matrix, and B are inverses of each other. So it means if you therefore, if they're saying that they're inverses, if I multiplied them together, I should get the identity matrix. So what we're going to do is I'm going to multiply them. I'm going to do matrix A by matrix B, and I'm going to do it the manual way. So what we're seeing, we've got 2, 3, 3, 5, because I want you to be practicing the manual multiplication, because it's a skill that is probably not going to be learnt by all, and that this will give us an advantage. You know, the weaker students won't get this. So let's go. So we've got a 2 by 2 and a 2 by 2. So when we do that, yes, it's defined. So we know because those two numbers are equal, it's possible. And we know our answer is going to be a 2 by 2. So remember what I said, when you're doing it manually, set it up. So I'm going to have 2 rows and 2 columns. So I'm setting up the little boxes to show where my elements are going to be. All right, so we know when we do this. So I'm going to do this first element. I'm in row 1 and column 1. So it's going to be 2 times the 5 plus the 3 times the negative 3. And then over on the right hand side, I'm in row 1 but in column 2. So it'd be 2 times negative 3 plus 3 times 2. Okay, and then I showed the next one. I'm down here in row 2, so it'd be with column 1. So 3 times 5 plus 5 times negative 3, and then 3 times negative 3 plus 5 times 2. So that's how we manually do it, and it would take a little while. Now what you're going to get asked to do on an exam is they probably won't ask you to do the whole thing. They will pick an element and they'll say, how is this calculated? So you've got to show that working out. Okay, so if we just wrote the numbers above those, and we can see that would be 10 and that would be negative 9. So if you're 10 minus 9 equals 1, and this is negative 6 plus 6, so I get a 0. Down here I get 15 minus 15, so that was a 0. And here I get negative 9 and a positive 10, so you end up with the 1. So I did end up with the identity matrix, so I have proved that they are the inverses. If you times them the other way, you will still get the identity matrix as well. So just to show you on the calculator how you could see this. So first of all, over here on the calc, I just did A times B and I got the identity matrix. Now, I also wanted to show you, if I did A and A to the power of negative 1, you can see I did that. That is the same. So it's like multiplying A by its inverse. And just to show you that A to the negative 1 it does end up equaling B, I just put it by itself to show you. So if you're asked to do if you're not asked to show how to create the inverse, so you'd only get asked to show if it was a 2 by 2. If you're asked what the inverse is, you just chuck it in your calculator, raise it to the negative 1 and show and press enter. So any bigger one like a 3 by 3 or a 4 by 4, you'll just be doing that. Okay, so let's go work out how we find the inverse manually. So what we need, the first thing we're going to look at is the determinant of a matrix. So obviously a determinant is only, you only use square matrices will have a determinant. And we only have to manually find the determinant of a 2 by 2, because everything else of a 2 by 2, anything bigger, we'll just use our calculator. It's a process. I don't even know it myself. So I only know how to find the determinant of a 2 by 2 matrix it obviously is a whole different process for a bigger one, and that will be, people will learn that if they go on to do maths at uni. All right, let's have a look. So we can often just say, when we want you to find the determinant, we'll say the det, and then we'll just put the letter of whatever they're labeling the matrix, so you can see there. Sometimes they might have those two lines on the side, but I very rarely see that. That's why it's not in bold or in blue. You're mostly going to get asked. So you can see, as I said, we're only going to get asked to manually do a 2 by 2. So you can see here we've got a basic 2 by 2, and we've put the letters in the element spot, so A, B, C, D, and that's so you can see when you find the determinant, what you actually do is you multiply the A spot with the D spot, so you can see that there, and you subtract it by the B and the C being multiplied together. Okay, so that's the rule. So you can see in the example here, we're going to do 2 by 5 minus 3 by 3. So, and then 2 by 5 is obviously 10, and 3 by 3 is 9, so 10 minus 9. So the determinant of that matrix is 1. Okay, so if we look down here, and we're just going to practice this. So if we went to find the determinant of this matrix A, I would do 2 times 5, so I'm doing the A spot times the D spot, minus the B, we could put it in brackets, minus 3, the B spot times the C. So then we end up with 10 minus 9, so that one is 1. If I do this next one, so the determinant of B, it equals 2 by 3 minus 3 by 2, and this one's determinant equals 0. So your determinant can be any number. It can be positive, it can be negative, and it can be 0. When it is 0, there is it is a special case. Okay, so but we'll look at that in a minute. So here, when I find the determinant of C, this one's going to be 2 times 3 minus 4 times 2. So it equals 6 minus 8. So this one was negative 2. So just to show you on the calculator, obviously these ones are really easy. A 2 by 2, you would probably manually work that out in your head quicker than it took you to type it in. But just to show you, all you have to do is actually type the letters D, E, T on your calculator, use a curved bracket, and then type your matrix in. So it would be the square, and then close it, press enter, and you can see. So here I did our examples on the calculator just to show you that it would equal like that. Okay, so why we had to find the the determinant manually is because you can actually see down here in the formula for inverse, you can see we have the determinant. So it's part of the inverse formula. So really though, you could get around it even by just going, here is the formula for so this is the manual formula. Manual formula for a 2 by 2 inverse, because we're only going to manually work them out if they're a 2 by 2. Okay, so because you can see that you can see down here that we do have the determinant number there, and it's part of the fraction part. So also, if you want to have a look, this part out here, and we learned this earlier, this is like a scalar number. In the end, it'll end up being a scalar number, yeah? Because we're going to and that which will multiply that matrix out. So you can see if I have 1 over 0, so if the determinant ends up being 0, so down here we said that, So what you're going to see, you would have 1 over 0 and then you'd be timesing. Now, you can't have 1 divided by 0. If you try to do 1 divided by 0 in your calculator, it will not like you. And so therefore, if the determinant equals 0, your calculator will spit out when you're trying to do the inverse, it can't be done. And it means it cannot be done. And we like to call them singular. So we would say, so maybe if you just want to write, if the det equals 0, matrix is singular, is what we call singular. Okay, so we've already seen this little fact down here. We saw it at the start. If you multiply a matrix by its inverse, you get the identity matrix. And anything bigger, we're going to use a 2 by 2. We use our calculator. All right, so let's do a practice. So you can see here, we're going to find the inverse of A. So first they found the determinant of A. So you can see they did 2 times 3 minus 4 times 2. So they got negative 2. So remember, when you're finding the inverse, so if I just wrote the rule, it's 1 over the determinant. And what you notice is the letters, the spots in the A and the D get swapped. So remember, if you remember, we said if we had a basic matrix like this, okay, oh gosh, my pen. Okay, if we have a basic matrix like this, when we're finding the inverse, so this first element is A and this B, C, you'll notice that these two numbers get swapped and then the B number becomes negative and the C number becomes negative, and then you would multiply out by that scalar number that you've calculated with the determinant. So you can see here, these two got swapped. So you can see the 2 and the 3 got swapped around and the 4 and the 2 became negative. And then what they did is they multiplied it out. So if you want underneath, we're going to I'm going to just put the fraction. So if you multiplied that scalar out, you would have it looking like this. And you can see that simplifies down if I still left it in fraction. I'll leave that like that, but that would be positive 2, 1, and this should actually be negative 1. So just take note of that, boys. That's a mistake. That should be negative up there. Okay, so let's practice. So I'm going to find, it wants me to find the inverse of matrix A. So first I'm going to work out the determinant of A, which would be 2 times 4 minus 2 times 3. So that'd be 8 minus 6, so we end up with 2, okay? So then when I want to find the inverse, it is 1 over the determinant. I'm going to swap those numbers round, the A and thing, and I make the other ones negative. Then I'm going to multiply out that half with those numbers. So it'd be 4 over 2, negative 2 on 2, negative 3 on 2, and 2 on 2. And if I simplified that, we'll end up with 2, negative 1, negative 3 on 2, and 1. So you can see I did it in the calculator. So if you don't have to show all the working out, you just chuck it into the power of negative 1, and you can see I got that answer. And then just to show you, if you need the decimal, just go control enter, and we can get the decimal answer there. Okay, now when we go to do matrix B here, so if I'm going to find the inverse, first I'm going to find the determinant, and it's 2 by 3 minus 3 by 2. So you end up with 0. So we should know, when it's 0, you can't get the inverse. So I showed you just to show you, I tried to put it in the calculator, and when I put it in the calculator, it told me it was an error, and it even tells you that therefore it's a singular matrix. It means you can't get an inverse, okay? So we just would stop there. So when it says find the inverse, you just say inverse cannot be found. Cannot be found because determinant equals 0, okay? Okay, so just going to do a couple little exam questions. So here it says the determinant of this matrix is equal to 9, and it says find the value of x. So all you have to do is like, all right, I've got the determinant. So the determinant we know is found by, it would have been 3 times x minus 2 times 6. And what they're saying is, they're saying that it's 9. So you know that that would have equaled 9. And if I just change that to 3x minus 12, so I multiplied that out. So once you get something like that, you've got an equation. So it means you can use your solve function. So you can just go solve, comma, x, and x ends up being 7. Okay, so with this one, it says, consider matrix A. So they've given me a matrix A, and they said A is equal to its inverse for a particular value of K. So what that means, if they're saying that A is equal to its inverse, it means they're going to look exactly the same, okay? So what you might want to do, you go, all right, so I don't know what to do here. So I'm thinking, I'm just going to find the inverse using what I've got there, okay? So first of all, if I had to find the determinant of this matrix, I would have said 3 times negative 3 minus k times negative 4. Okay, so if I tidied that up, that would be negative 9 plus 4, yeah? Would you agree? Yeah? So then when I find the inverse, we know that the inverse is 1 over det, and then you swap these two and you make these ones negative. So if I did that here, I'd have 1 over, and all I'm going to do is put that determinant there, and then I'm going to swap these two numbers, which means negative 3 and 3, and then this one would become negative k, and that one. What do you think happens when you have a negative and you're supposed to make it a negative? What do you think? A negative will become a positive. Okay, so we hadn't talked about that. So if the number's already negative and you're told to make it negative, it changes. So then if you look here, we want, when we multiply this out, this scalar with this, we want it to look like that. So if you look up there, here's a positive 3. So if I want to change that to a positive 3, what am I going to have to multiply it by? A negative 1. So that means, and this question's quite hard, I reckon. That means I know that this determinant number out the front, or this scalar number at the front, needs to equal negative 1. Okay? So when we, so then when you press solve, you can just chuck in solve at this point and go comma k, because you don't know what k is. And I think you end up with k equals negative 2. Okay, so we end up with that. This one, don't stress too much. I reckon it's quite a difficult question. Sorry, it's positive 2. Yeah. K equals 2. Sorry. Okay, example 7. A and B are square matrices such that A times B or B times A equals the I, which is the identity matrix. So we should know that if you times something and by something else and you end up with the identity, that means that this is the inverse. So this is the inverse of A, okay? So you know that, and it's the vice versa. A is the inverse of B. So if you have a look, it says which one is not true. If you go across here, if you multiply just A by B, you get the identity. So the identity is like a number 1. So then if I times the identity by A, yes, I'm going to end up with A. So that's true. Now, if you times here, when they say you've got A times B squared, so you're really doing all this. So you've got 2 A's and 2 B's. It's still like the inverse. They're all going to cancel each other out, and you're going to end up with the identity. So that one is true. Now, with C, it says B must equal A. Is B equal to A? No, it's just the inverse. So you already know that is wrong. So the rest, and then it makes sense because D says B is the inverse of A. So that is true. And both A and B have inverses. That is correct as well. So 10E questions 1 to 4.